Hi, I'm Rob, N1NUG. Today, we're going to be taking a look at this TinySA Ultra that SeeSii sent me to review. Now, if you want to purchase one of these, the best thing to do is to go over to the TinySA.org website and check the link of approved vendors. There are a lot of counterfeits out there that you can buy that just simply don't work or don't work right. So you want to make sure that you purchase one from that list of approved vendors. Now, of course, this one from SeeSii is on that list, and if you're interested in this particular device, I will have an affiliate link down below and even possibly a coupon code that you can use to save a little bit of money. This video is not intended to take the place of the manual for this thing. If you've bought one of these or are thinking about buying one, check the link in the description below so that you can go to the product page and find all the documentation that is available for this thing. Here's a quick look at everything that comes in the box. Now, first up, there is a QR code and a link to where you can find the manual and other instructions for the TinySA. You, of course, get the TinySA Ultra. You also get a wrist strap that'll go around one of the corners here, and a guitar pick that's attached so that you can use this to kind of activate the screen as needed. You also get a USB-C charging cable. If you don't like the guitar pick, there is sort of a little pen stylus that you can use to activate the screen. It also comes with a telescoping antenna that has an SMA connector on it so that you can use this thing out in the field. There's a double-ended SMA female coupler, and we get two 1-foot-long coax patch cables with SMA male connectors on either end. So I'm told that as of 2024, it's mandatory to do a screen peel on camera of any device that has a screen protector shipped on it. So here you go. Now a quick overview of the TinySA. Of course, on the front is the 4-inch touchscreen. Over here on the side are two SMA connections. This one is sort of the RF in and out, and this one is for calibration. The TinySA does ship with dust covers for the SMA connectors, and when the ports are not in use, it's recommended to keep these dust covers on to help prevent static discharge from damaging the unit. On the bottom, we have a USB-C charging port. This is where you can also interface with a computer. Over here is a micro SD card slot, and mine came with an SD card installed. And then over here is actually an 1/8-inch headphone jack. Up on top, we have the on-off switch here. And then over here is the navigation control. It's sort of a rocker switch that goes left and right, and you can push down straight on it to activate things on the menu. And on the back, we have a label with some basic information and a QR code and a link to the TinySA website. I apologize for the glare in the screen, but I really haven't been able to do much to kind of mitigate it with the lighting in here. But I think once we turn this on, you can see that we'll be able to see the screen just fine. When the TinySA first boots up, it comes up in spectrum analyzer mode. And right now, it is looking at the spectrum between 0 and 800 megahertz. Now, this thing can go up to 6 or even 12 gigahertz when ultra mode is enabled. We'll take a look at that later in the video. You can see along the bottom here, what we're looking at is basically the noise floor in my room right now. And that's looking to be somewhere around -95 to a -100 dB. Now you can see here, there's a few spikes that kind of come and go depending on what signals or other noise spikes the TinySA is picking up. And every time it finds that maximum spike, it moves the marker to that spike and then shows the frequency and strength of that spike that it's measuring. So now I'm going to bring in sort of a standard key fob to generate a real signal that we can look at with the TinySA. So if I push the unlock button, you can see we get a spike right about at 433.8 megahertz. If I bring in another key fob and press the unlock button on that one, you can see we're measuring a frequency of 314.4 megahertz. And that's sort of the basic operation of a spectrum analyzer. But there's a lot more that we can do with this to kind of measure and track signals. The first thing that I can do is touch on the screen, and I can change the frequency range that the TinySA is scanning if I want to take a closer look at a particular section of the band. So right now you can see we're starting at 0 hertz and scanning all the way up to 800 megahertz, with the center being 400 megahertz. So let's limit that And let's start at 400 megahertz. And let's stop at 500 megahertz. And then you can see if I go back into the menu, the TinySA automatically sets the center frequency or center of the display at 450 megahertz. And we have a span of 100 megahertz automatically calculated. So now if I bring in the Subaru key fob, you can see we're seeing it right there in the middle of the spectrum, right at 433.96 or so megahertz. We're getting a little bit better resolution on that frequency measurement. And now if I bring in the Toyota key fob and press that button, you can see it doesn't show up on the TinySA because its frequency is outside the window that we're currently measuring. If I want to get even more precise, I'll do 430 megahertz for a start, and for a stop, I will do 435 megahertz. And you can see the center frequency is right at 432.5. Now that we've narrowed up the bandwidth, you can see that we're actually seeing a weak signal here at 432 megahertz or so. It's down about negative 88 dB or so, just above the noise floor. And at first I thought it was maybe coming from one of these key fobs, but I took them out of the room and it's still there. So clearly something else is causing that spike. Anyway, if I now push the unlock button on the fob, you can see that we get a better look at that signal that the fob is transmitting. So now if I have something interesting on the screen that I want to capture and kind of stop and take a closer look at, I can go into the menu and just click the pause button. And you can see now the measurement stops and we have a snapshot of what's on the screen. And what I can do now is use the toggle up at the top, and I can scroll that around to find information about what I'm looking at. Now at the top of the big spike that's generated by my key fob here, we can see that the frequency is now at 433.908 megahertz with a strength of negative 65.3 dBm. Now I can use this to kind of scroll over and find that other peak. And at the very top of that peak, we're looking at a frequency of 431.993 megahertz at a signal strength of negative 88.3 dBm. Now if for some reason I want to store that snapshot, I can go into the menu again, activate storage, and I can do save capture. Then the keyboard comes up so I can name it. Then if I hit enter, it saves it to the SD card. Now if I want to resume measurement, I'll just go back, uncheck pause, and we're back in measurement mode. So even though the TinySA is working and appears to be working just fine, if we want to take more precise measurements with it, it's probably a good idea to calibrate it and do a self-test. So in order to do that, I am going to connect up one of the patch cables to each of the connectors on the sides. Now I'll turn the analyzer back on, and we'll go into the config menu. Under the config menu, I'm going to first do the self-test. The analyzer will go through a series of tests to check itself and let us know if everything is okay. So it looks like all of the tests passed, and down at the bottom it says touch the screen to continue, so we will do that. Now I'll go back into the config menu, and this time I'll do the level calibration. Now I'm never going to need to use this analyzer above 5 gigahertz, so I'm going to stick with this first option. Now if you're going to use yours above 5 gigahertz, there is a special calibration procedure you'll need to follow. I'll leave some links down below that will help you with that. So for now, I'm just going to pick this first option. You can see we're instructed to connect the Cal and RF, which I've already done with the cable. So now I can just click Calibrate. So after going through several steps, the calibration is complete and we're ready to go back into measuring mode. Up to this point, we've been looking at a single marker that measures the strongest signal that the analyzer is picking up at any given time. Now in some cases, I'm going to be interested in seeing more than just one peak at any given time. To add more markers and measurements, I can just go into the menu and choose the marker option. And you can see along here there's some various options for setting the markers. Now in my case, I think I'm just going to choose 4 markers as a quick option. And now we can see 4 different measurements and 4 different markers on the screen. This is an old Alenco DJG1HT. I'll do a direct test of the radio into the analyzer later, but for right now I'm just going to go across the room with the radio on low power, and I'm going to transmit, and let's see how many spikes we see. Now we should obviously see one at the main fundamental frequency, but it's going to be interesting to see if there are any other harmonics being generated by this radio about 10 feet away. It's important not to get too close to the analyzer with a strong transmitter. You could overload it and damage it. And we'll talk more about that later in the video when I hook the radio up directly to the analyzer through an attenuator. Watch what happens when I key up the radio. So at this point, you can see there are a few signal peaks here that we're looking at. Now some of them are kind of bouncing around, and I think that's just background noise in the room from my computers. But the 2 markers at 1 and 2 are pretty steady. And right now, because the analyzer is set to sort of a wide bandwidth, we're not getting a real accurate frequency measurement, but you can see that the first marker is reading 146.4 megahertz at negative 15 dBm. And you can see that marker number 2, also staying pretty steady, is measuring 293 megahertz or thereabouts at negative 60 dBm. Now the other thing that you may notice here, the scale on the right side of the analyzer that measures the signal strength has automatically adjusted itself and is now 20 dB at the top and negative 70 or so at the bottom. The analyzer was able to recognize the relatively strong signal and kind of adjust the measurement for optimal viewing. So what I think I'll try next with the TinySA is to measure the harmonics put out by this Baofeng HT. I'm not going to go into a great deal of detail about my setup, but I will mention that I have 40 decibels worth of attenuation between the radio and the connection to the TinySA. And that is so that I don't put too high of a signal into the TinySA and blow it up. I'll leave some links down in the description below that will give you a little more detail about attenuators, why you need them, and how to choose one. So I've got the Baofeng connected up through the aforementioned attenuator into the RF jack on the TinySA. I'm going to be transmitting at 146.52 megahertz in the 2-meter ham band, and I've got the radio set currently on high power. So it should be putting out about 5 watts. Before I start the test, I'm going to go into the menu and I'm going to go to the level setting, and I'm going to set my external gain to negative 40 times 1. And that will compensate for the attenuator that I have in line. Now after that's set, you may be able to see the measurement scale over here on the right has gone from negative 100 dB to negative 60 dB or thereabouts. Now I can set up the harmonic measurement test by going back to the menu and going into the measurement mode. Once I'm here, I'll choose harmonic, and I'll first enter my center frequency, which is going to be 146.520 megahertz. Now at this page, I'm going to enter in the center frequency of each of the measurement spans. Now a common thing to do is just enter in the fundamental frequency so that each span is separated by 1 harmonic of the fundamental frequency. The other thing that you can do here is just enter 0 and have the screen just show the whole measurement and not divide it up into spans. But I think for this demo, I'm going to enter in the 146.52 so we get the individual measurement lines. Now I'm ready to key up the radio and we can start looking at the measurements. Now it's going to take several seconds for this thing to kind of settle out and get to a final measurement. As you can see, it's kind of averaging as time goes on. Now that everything is settled out, we can see that at the fundamental frequency of 146.5 megahertz, we're getting a measurement of negative 3 dBm. And that's about what it should be, considering the fact that we're putting out 5 watts on the radio and have a 40-watt attenuator in line. Now we can see here the second harmonic, or 146.5 megahertz above the primary, we're getting a measured spike of negative 50 dBm. And then at the third harmonic, or 293 megahertz above the primary, we're getting a spike of negative 44.8 or so dBm. Once I unkey the radio and the signal is lost, the TinySA will kind of go back to 0. While we've got everything set up, I think I'll test this old Kenwood THF6HT. I've got the frequency set to 14652, and we'll be transmitting on high power, which is 5 watts. Let's key up and see what we get for a measurement. Once everything settles out, we're not seeing any harmonic spikes from this radio, just the fundamental frequency of about 146.5 at -3 dBm, which is what we should be seeing. Now there's two major differences that set the TinySA Ultra apart from the original TinySA. The first difference, of course, is the size. This is much bigger than the original. The second is the fact that we can get this thing into ultra mode and get that top limit of the frequency that this will scan up close to 6 gigahertz. So let's check that out now by going into the menu and choosing the config option and then more, and then we'll enable ultra. You may have seen that brief message pop up about acquiring the unlock code from the website. Well, I've already done that, and it's 4, 3, 2, 1. And enter. And now we are in ultra mode. Now that we're in ultra mode, you should be able to see that we're starting off at 0 and going all the way up to 6 gigahertz. You can probably also see that the scan speed is now very slow. And that's because it's got a lot more bandwidth to cover than it did when it was in regular mode and topped out at just 800 megahertz. And these two spikes here are actually the two Wi-Fi routers that are in my house. One's at 2.4 gigahertz and one is somewhere up around 5 gigahertz. Let's see if we can get a little better snapshot on the one at 2.4 gigahertz by narrowing up the frequency range. So we'll do the start frequency at 2.2 gigahertz and we'll do the stop frequency at 2.6 gigahertz. Now you should be able to see the scan speed is much better and we're getting a better look at that signal spike coming from my router at 2.4 gigahertz or thereabouts. So it's nice to have that capability up to 5 gigahertz, but for me, most of the time working in ham radio frequencies, I'm not going to need it in ultra mode. So to get it out of ultra mode, I can just go back into config and turn it off. And then we're back to normal. Now there's actually a ton more capability in the spectrum analyzer mode on this TinySA Ultra. But to keep the video a reasonable length, I think I'm going to switch over and take a look at the frequency generator next. So to go into signal generator mode, we just go to the menu and select mode, and then click signal generator. When the signal generator first fires up, it goes to 10 megahertz by default. Now we can change this by just kind of clicking and sliding around in here, or if we click in the middle, we can actually enter in a specific frequency. So for right now, I'm going to choose 7.410 megahertz. Now the signal level sets itself to the max, or negative 17.5 dBm. And again, we can slide this around if we want to, all the way down to negative 120 or so. Now just like the frequency, we can actually pick a specific dB level by clicking in the middle where it says set and then typing in what we want. Negative 73 times 1, and you can see it now sets to negative 73 dBm, which is an S9 signal. Now this signal generator can also be modulated with a tone in either AM or FM mode. So for right now, I'm going to pick AM, and I'm going to enter a frequency of 741 hertz, of course. Now we can also set the AM modulation percentage or the FM deviation. I'm going to leave those at the default for now. Now we can also set up a sweep generator if we want to, meaning it'll sweep the frequency between a certain range. I'm not going to do that right now for this test. We're just going to use it in straight signal generator mode. This entry here can be used to compensate for an external attenuator that might be connected in line. Now right now I don't have one, but if I did, I could type in the value of the attenuator and it would compensate any measurements for that. Under output, we can select between the cleanest signal possible or the highest accuracy possible. And then there's also additional configurations under here that I'm not going to get into for right now. And then the mode entry down here at the bottom is how we could switch back to the spectrum analyzer if desired. So for a quick demo, I've brought in my Yaesu FRG 7700 shortwave receiver. I've got the TinySA up here connected to its telescoping external antenna. Now both the radio and the TinySA are set to a frequency of 7.41 megahertz. I've got the TinySA currently set up to output its maximum of negative 17.5 dBm. I've also got the modulation set to AM mode with a depth of 80% and a tone of 741 hertz. And I've got just a piece of wire connected up for an antenna on the shortwave radio for now. So now I'll turn on the generator and we should be able to hear it come through the receiver. So obviously we can hear the tone, and you should be able to see the signal meter is pointing right here at about S9. If I move my antenna closer or further away, the signal of course strengthens or weakens depending on where I am. So now if I change the output level on the TinySA, the signal should weaken. So now we're down around negative 33 dB, and obviously you can hear it's not as strong as it was before. For the next test, I've got the TinySA connected directly to the antenna jack on the Yaesu. Now I want to be careful that I don't overload the receiver on the Yaesu and cause any problems. So before I turn on the signal generator, I'm going to set the level to negative 73 dBm, which should give us an S9 reading on the receiver. So I'll fire up the signal generator. Let's take a look at the signal meter and see if we get S9. So I'll turn the volume up for a second, and you can obviously hear that tone and the fact that the signal is nice and strong. And if you look at the signal meter, you can see that the needle is a little bit above S9. Now, this radio is over 40 years old, probably could use a little adjustment, so I'm going to assume that the needle in this radio is not accurate and that the TinySA is probably close to accurate. Now just to do an experiment, if I set the level 20 dB above what it is now, or negative 53 dBm, this needle should go up to about 20 dB over S9. And as you can see, it's actually up closer to 30, but again, I'm going to assume the radio is not accurate. Now let's see actually how low of a signal we can go and still have the radio be able to receive it. So I want to go down around negative 84, and we're still getting it pretty strong, right around S7. Let's keep going down and see what we get. So there's negative 101, and you can still hear the signal, but there's a little bit of noise coming in with it now, and the needle is sort of down here around S1. We're still hearing the signal at negative 110, and then even down at negative 122, which is the lowest limit for the TinySA, the signal is still coming in pretty strong. So I guess if I want to test the bottom limit of the receive sensitivity of this Yaesu, I'll need an external attenuator in line to cut the signal down more. So now just for fun, I want to test out the FM modulation. So I've set the level back to negative 73 dBm, or S9. We're still in AM at the moment, and you can see we're back to where we were when we started. Now, if I change the modulation mode over to FM, and then turn the volume up, and set the radio to FM, there's our tone, everything sounds good, and the signal is up around S9 again, where it should be. And then again, just for fun, if I change the signal level all the way down to negative 122, we're still hearing that signal fairly strong on the radio. That was just a quick demo to just kind of give an overview of how the signal generator works. Now in my case, I'll probably end up using the signal generator most often to do radio receiver alignments. In a lot of cases, the service manuals for these radios will specify that a signal of a certain frequency and certain level and certain modulation tone needs to be injected at certain points in the circuit to get the receiver aligned correctly. And I think this is a handy and relatively inexpensive tool to get that job done. So I hope you enjoyed my overview of the TinySA Ultra. If you think this is something that you want to learn more about, I will leave a product link down in the video description below. Anyway, thanks for watching, and 7-3. Let's see, this has got to come down. Hello. We'll go in front of the radios. Just a quick demo to kind of show how the signal generator, oh my god, I can't speak. Generator.